Welcome to Chemistry 2. This is Lesson 2, Video 1. In this video, we are going to discuss the differences between solids, liquids, and gases in a lot of different manners, but we're going to focus on intermolecular forces and how they can affect what state of matter we have. So if you recall, we covered all of this in Chemistry 1. But a solid, when we're looking at a solid state of matter, the particles are close together. And we have an ordered structure to these. In a liquid, there is more space between particles, whether they are atoms or molecules. And in a gas, there is even more. So we have lots of space between particles. So close together, a little bit of space, lots of space. And remember that the distance between particles is going to play an effect on the strength of intermolecular forces. Now, excuse me, all of these molecules are moving. These don't move past one another, but they do vibrate back and forth. If you recall that temperature is directly proportional to the speed of molecules, so the faster they move, or the higher the temperature, the faster the particles move. So they will start to vibrate, and once they vibrate so much, and we have a solid going into a liquid, then the molecules or particles can slide past one another. And that is a liquid. Particles can slide past one another. We increase the temperature even more, the molecules or particles are moving even faster, and then they can escape from the liquid phase and go into the gas phase. So these are very fast moving. Because of that, liquids and gases have random structures. Gases basically really don't have any structure whatsoever. Liquids have a little bit. And we use shape and volume, either definite or not definite, to describe these. So a solid, we can measure its volume. If it's a regular solid, we can use a formula like length times width times height for a cube or a rectangular solid. So it has a definite volume and a definite shape. Liquids, we can measure their volume using a graduated cylinder. So they have a definite volume, but they take the shape of a container. Gases, no definite shape nor volume, because the volume of a gas can be compressed, so we end up not having a definite volume. When you talk about gas laws, you have to define the temperature and the pressure of the gas in order to calculate its volume. So based on these, we can get other things to diffuse into them. Solids, little to no diffusion. So if you put two solid pieces of substance together, they really don't diffuse into one another. You might get a couple atoms or molecules right at the surface, but that's about it. Liquids, they can diffuse. So we know that if we put something in water, that it can spread out in the liquid. And gases usually diffuse very easily. You could use room deodorizer, like the Kansas spray freshener that you get. that travels throughout an entire room. That is because the molecules are bumping into gas molecules and spreading them around. So the last thing that we'll talk about here is the intermolecular force strength. So if you think about it, we said that it had a lot to do with how close the particles are to one another, because if something is close to one another, intermolecular forces can catch a hold of something and hold it together. So with IMF, these have usually strong IMFs that hold it together, and gases have weak IMFs. Liquids are between. So the strength increases with solids, liquids in between, and gases. The intermolecular forces are not as prevalent because there's a lot of space between the molecules. So they really don't have a big effect on a gas. But they can hold something together, but only if the particles are close. So this is going to play into some of the properties that we see of solids, liquids, and gases. And we're going to focus mainly on liquids in this unit.